the old-fashioned red lens.
We do have some items for take and trade for donation, bookmarks, some What's Hot on the Moon books tonight, some t-shirts. I guess we're out of coffee cups.
Yes, we're out.
And some really large posters over there for $2 a crack and everything else. And I'm going to get out of the way, and then if you like what we do and you can spare a couple of bucks, that's great. And if not, that's great too. Have fun.
All right, well, my name is John Ensworth, and for the last couple of years I've been doing little news updates in the astronomy world, trying to keep it current here before our main speaker. So I chose, it was easy, there's so much new stuff pouring out of the astronomical world right now that it's easy to pick things that are kind of thematically linked. So we got some breaking news on exoplanets. These are planets outside of our solar system, so that's the exo part. And 3 brief little stories here. First, we have 2 free-range planets found. What's a free-range planet? That's a planet drifting between stars. It is not orbiting a star.
You mean it's not an organic planet?
It's not organic, no.
Happy planet.
And no GMOs. Yeah. Also, rogue planets, not Rogue One. That's another confusion. This was discovered as part of the optical gravitational lensing experiment, which I guess OGLE is easier to say. We have about 17 planets or candidates for rogue planets out there. The first one, ending in 1323, is between the size of Earth and Neptune. And the second one is about Jupiter to maybe a brown dwarf in size. And a brown dwarf is a star that is not quite a star. It's not big enough to have nuclear fusion occurring in its core, but it still can be giving off a lot of infrared radiation. And so here's a little animation that shows you how these were detected. So here is, where they're looking, here's the light curve over time, how bright it gets, just winks. And what's happening is that the planet is moving through space. It happens to go in front of a star, and gravity acts like a lens. You saw some gravitational lensing going on in the pictures beforehand in the movie we were playing. So gravity bends space-time, and it acts like a lens, just like a chunk of glass, and does interesting things with the light. So we look for that little blink of light. Much easier to do from space, where you don't also have the noise of the atmospheric scene going on to make stars wink also. Next one is Barnard Star's planet. Barnard Star. Anybody hear of Barnard Star before? All right, well, he wants it back, so it's his star. It's the second closest star system to our sun. It's the 4th actual closest star by distance, because the Alpha Centauri system, closest to us, has 3 stars in it. This is only 6 light years away, so it'd be cool if you had a planet here. You could go visit it. E.E. Barnard described its proper motion in 1916, but it was seen on plates back in the 1800s. It's a very old, small red dwarf, very cool star, and it's notable because it is the fastest moving star across our sky. So when we look out and measure the apparent velocity of stars, this one is the winner. Barnard Star B is the name of the little planet. Seems to go around in 233 Earth days. It's about half the distance away from Barnard Star as we are from our sun. But because that star is so small and cool, it only gets about 2% of the sunlight that or starlight that the Earth gets here. So it is a very cool planet. 274 degrees below 0 Fahrenheit. The Red Dot team made the discovery. They're the ones that also announced the planet around Proxima Centauri, which is one of the 3 stars closest to Earth, Proxima. They use the Doppler effect wobble of the star to detect this and tell what's going on, and use these instruments down here. So there's the red dots group. They have different number of different astronomers working from different nations, using whatever equipment they can and need to. So here are their two finds here. If you wonder where Barnard's star is, it's down here. This is the summer triangle with Deneb, Altair, and Vega. Go down into the south where Ophiuchus is. It's up here. And if you took pictures of Barnard's star over time, 1991 to 2007, that's how far the star moved. And these are in between years that they took pictures of it. Yes?
Yeah, I read a synopsis today, just today.
Okay.
What's the star that's 4 light years?
Alpha Centauri? Or?
That one, they have discovered a planet around too.
Yeah,
That
that's...
was today.
that one, yeah, this is their... yeah, is it Ross 154? Yeah, is that what they're showing? Yeah, this is a group that discovered that one. But it too is probably very cold because that's a real red dwarf. And this red dwarf puts out a lot of big solar flares. So it's probably been sterilized, if anything did try to get started life-wise. Here's an artist's picture of what it might look like if you had really big eyes. It could pull in more light on the star around Barnard, planet around Barnard's star. And our last one is the revenge of Oumuamua. We talked about this in a news update from last year. This is the interstellar rock traveler that came through our solar system. It was discovered October of 2017. Its name is Hawaiian for scout or messenger. The very last observation that we've been able to make with Hubble was January 2nd of this year, and it now is dimmer than magnitude 27. And soon it'll be beyond the orbit of Jupiter. Estimated about 2,600 by 260 feet. So it's very long, kind of cigar-shaped. Entered the solar system with, if you say the entry point in the solar system is 1,000 AU, which is sort of arbitrary, that happened around 1837. It'll be back that distance out from the sun about 2196. It'll get to the inner Kuiper belt distance from the sun about 2025. It'll match the Voyager's most distant distance from the sun currently in about 2038. So here's the path it made sailing through our solar system. It was zoomed in closer than Mercury. And what we have, the thing that made the news is all the oddities about the measurements that we've made. So Marco Micheli and some other astronomers reported that it's not moving as it should. Instead, it showed a really strong non-gravitational acceleration. And when you have people already going, this looks like a spaceship, then that gets everybody really excited, and it did. Some news outlets kind of took it and ran with it. But they do say clearly that its motion indicates that gravity is not the only thing dictating its path. They see the same level of sort of velocity altering from just it sailing through space you would see with outgassing comets. But when they use every tool they can looking for small dust, large dust, and cyanogen, which is a proxy for water, which is a lot harder to observe, they just don't just see it within the detection limitations that they have with the instruments. They think they should see something coming off of it to account for this, and they don't. Its infrared signature, looking at using the Spitzer telescope, is absent. So is it brighter than a comet? Comets typically reflect about 4% of the sunlight. Maybe it's up around 10%. Why? Well, it's interstellar. Maybe that answers it. I don't know. They have tried to figure out looking back through its orbit, using every single observation as far as they could get through its path, and using the latest star positions and motions reconstructing where stars have wandered around us in our local arm of the galaxy, where this may have come from. And there are 4 candidates where it would have passed within 2 Oort cloud radii of those stars, and that's 100 to 200,000 Sun-Earth distances out from those stars. But it's moving too fast. It would have had to have gotten a tremendous launch from one of those systems. You can kind of see how that could happen if one of them were binary, but none of them are. So maybe it's come from someplace much further out, so its launch happened much further back in time, so a lot more motion among the stars has made it a lot harder to figure out where it came from. But we don't think it's a piece of space sail that's broken off from an alien probe and is traveling unusually through a solar system, picking up pressure from the sun, or aliens riding things around. So it's science, we'll figure it out. So, all right, thank you very much. I'll turn you over to our speaker tonight.
Well, while we're getting the microphone changed over to our guest speaker, I have a couple of things I'd like to chat with you about. My name is Jay Wilson. I'm one of the volunteers here, wearing one of these round name tags. And if I could ask all the other volunteers around here to sort of raise their hands so the crowd can see who you are, please get a hold of one of these volunteers. Most of them have name tags, some don't. But please get a hold of one of them if you have any questions at all about the observatory, how you might volunteer here yourself, or how you might bring your family here for a private night with the telescopes. We'd love to talk to you about that. So who's here for the first time? Oh, wow. I hope you really enjoy it tonight. I think we have a fun program. I don't think the skies are going to cooperate for us to do an awful lot of telescope viewing, but we will be glad to take you up in the domes after the talk, let you look at the telescopes, see the kinds of things we do with them, and talk to you about scheduling another visit. We'll have another program in December that will be a follow-up to tonight's program. So if there are any unanswered questions from tonight's program, in December, Scott Kent is going to be talking about the science behind the search for extraterrestrial intelligence. So that will be a more scientific focused program. Tonight, we're really privileged to have Sarah Scoles as our guest speaker. Now, Sarah has a background in astrophysics. That's what her degree is in. But she wanted to be able to tell the story of science and physics and astronomy in a way that would be approachable to people like you and me. Something we could understand on an actual concrete level. So after getting her degree in astrophysics, she went on to get a degree as Master of Fine Arts from Cornell University in fiction. Now, I don't know how those two work together. But the combination of those two things make her a good science interpreter for the world. So she has worked at the Green Bank Observatory, previously the National Radio Astronomy Observatory, where she met just about everybody who's important in this field. She's written a book called Making Contact, and it's available on, well, the whole title is Jill Tarter and the Search for Extraterrestrial Intelligence. It's a science-based book. This is not a work of fiction. And it really tells a compelling tale. Are any of the ladies here interested in working in science? I'll bet you are. You look like you're going to be a scientist, right? Anybody else? You too? Well, this will be an inspiring book for you because the story of Jill Tarter, and I don't want to take away from Sarah's program, but the story of Jill Tarter is absolutely exciting. Somebody who, from their earliest days in school, knew they wanted to work in science, but they had a few challenges to overcome along the way. Jill became, and is presently, one of the most respected scientists in the world. And one of the areas of specialty for her is the search for extraterrestrial intelligence. Sarah knows her, has written the book about her, and what a great resource. You can buy this from most bookstores or from Amazon. Sarah may tell you other ways of getting it. The other thing Sarah has done that's important to us is she was an associate editor of the Astronomy magazine. This is one of the two leading magazines in the world on astronomy. And so for quite a long time, she was the associate editor. She's currently a contributing editor to Popular Science and several other science publications. And she does freelance writing out of Denver. And rumor has it, she's also a trail runner and a very accomplished drummer. So Sarah, thank you for being here.
Thank you. Hey everybody, is this microphone working?
Yeah.
Okay, awesome. Thank you guys for coming out tonight. I really appreciate it, especially before it's about to ice rain on all of us, I think. I think I have two intro questions before we get started. One is, who here thinks there are aliens out there?
I don't just,
I don't know if you guys heard that, but this guy knows. My second question is, who's seen the movie Contact or read the book? Oh, wow. That's better than usual. It's 20 years old now, so sometimes people haven't seen it quite as much as they used to. It came out when I was 12 years old, so I was very impressionable, and I became just very obsessed with it. I didn't realize that searching for extraterrestrial intelligence was something you could do for a job. It didn't really sound like a job to me. And so that's what got me interested in radio astronomy and this whole thing, and then eventually I found out that the main character in the movie Contact was based on this real person, Jill Tarter, and so then when I grew up I convinced her to let me write a book about her. It took a little convincing, but eventually she was like, okay, you can do that, leave me alone, that's fine. So she has spent her whole career, around 40 years, looking for signs of extraterrestrial intelligence, and maybe you heard something, but she hasn't heard anything from them yet, unfortunately. But there have been a few times in history when people have thought that they have heard or seen or found extraterrestrial intelligence in some way, even before the spaceship rock from last week. And just to get started, this is a quote from the movie Contact and the book by Carl Sagan, Contact, which is, "If it's just us, it seems like an awful waste of space," which I think also. And the question, are we alone? Is it just us? Is something that people have been asking basically since people asked any questions at all and looked out at the universe. But this is really the last 50 or so years have been the first time we've ever been able to actually investigate it scientifically. And some people like thinking the answer to that question is, yeah, we are alone. We're very special and we're the center of the universe. I don't like that. It makes me uncomfortable. If you guys believe there are aliens out there, it seems like probably you don't like it very much either. Like, it makes more sense for a universe that big, with all of those galaxies, to have something living in it besides just us. But there are other reasons besides the universe's bigness and its age to believe that there might be something else out there. The first is a group of beings called extremophiles. Have you guys heard of those before? Yeah. This is a favorite of a lot of people. Can you see this laser pointer, or should I use the other one? It's okay. Has anybody seen this friend before? It's called a tardigrade. It's not as big as a mountain. It's very, very small. It's a microbe. And it's a pretty cool extremophile. Extremophiles, if you haven't heard of them, are just living things that can live in very extreme environments. And this particular guy can take all kinds of extremes. Let me make sure I get it right. It can live in the vacuum of space. Like if you throw a tardigrade outside of a spaceship, it'll survive, which is not true of any of you. And they don't need water for 30 years, which is like how long humans used to live. And what else? I don't want to miss anything. Oh, they can be hundreds of degrees below zero, which obviously goes along with being out in space. And other extremophiles can live like in the radioactive cooling pools around nuclear power plants, basically in battery acid, super, super salty things. Basically anywhere on Earth that something could live, some things are living. And so that has made astronomers think, hey, if everywhere we look here, we find life, even these places that we find really inhospitable, maybe the same is true on other planets that we also thought might be inhospitable. And the other thing that has changed since SETI started is that we also have a lot more exoplanets than we used to. When SETI started, people actually, sorry?
Zero.
Right, yeah,
Last 2 decades,
there was zero.
That term of the Drake equation has gone from 0 to nothing to 1.
Yeah.
Literally.
Yeah, definitely. And when they started, they not only hadn't found any, but they also thought that it might even be unlikely. Like they thought our solar system might be the only one. They thought it was really hard to form planets. But a little less than a decade ago, NASA scientists launched a telescope called Kepler that has found thousands of planets and has thousands and thousands more candidates. And what it did was it just stared at like a small patch of sky. Like imagine if that air vent up there was the patch of sky it was looking at, and they tried to find how many planets were in there and then extrapolate to the rest of the galaxy. Like if that's what's there, what do we think is out in the rest of the galaxy? And we know now that basically every star has planets, and lots of them probably have planets that are rocky like Earth. And so if you put those two things together, there are weird tardigrades floating by rainbows and mountains, and all of these exoplanets, then it makes more sense that there might be alien tardigrades on alien planets. But ever since we started trying to find out if that was the case, which was around 1960, there have been these false alarms where we think we've seen something and it turns out we haven't. So literally the very first time anyone tried, they thought they found something and didn't. And that very first experiment was done by a man named Frank Drake. This is him in, I don't know, the early mid-2000s. He's in his 80s now, but in the 1960s he was a young astronomer and he had this idea. He worked in Green Bank, West Virginia, where I used to work. I actually lived in his house for a little bit. He was not also there. I was there and he used to live there. But he convinced the director of the observatory, like, hey, nobody's ever looked for radio signals from extraterrestrials. Maybe we could give it a shot and just see what happens. And at first the director was like, no, that's not a good idea. And then he heard about some other people at another university who were thinking of trying it, and he was like, okay, let's do it right now before those other people give it a try. So it was a pretty small experiment. He looked at 2 sun-like stars, kind of the size and age of our sun, and was trying to see if there were any what we call narrowband signals coming from them. So like basically a radio station, something that only comes in at like a very narrow range of frequencies. And he would go up there every night. He would climb up into this thing up here, and he had to manually change a bunch of stuff first thing in the morning. And I was going to read a section of the time that he thought that he found something. So he wrote this in a book called SETI Pioneers. Whenever you search for extraterrestrial intelligent radio signals, you always feel at the beginning that the signal may pop up right away. A few minutes went by, and then it happened. Wham! Suddenly the chart recorder started banging off scale. We heard bursts of noise coming out of the loudspeaker 8 times a second, and the chart recorder was banging against its pin 8 times a second. We'd never seen anything like this before in all the previous observing at Green Bank. We all looked at each other wide-eyed. Could it be this easy? We'd thought the detection of a signal so unlikely that we'd never planned what to do if a clear signal was actually received. Almost simultaneously, everyone in the room asked, "What do we do now?" Boys. Well, the most likely source of a spurious signal was the Earth, and we could check that out by moving the telescope off the star and seeing if the signal went away. So when we proceeded to do that, and as we moved off the star, sure enough, the signal went away. So we pointed back at the star. The signal did not come back. Wow, was it really from the star, or had it been from Earth, and had it turned off about the time we moved off the star? What did we do? Day after day, as we turned to Epsilon Eridani, which is the name of the star they were looking at, we tuned to a frequency on which the signal had been heard. We listened for half an hour or so, and then we'd go back to our frequency scanning. We also connected a second receiver to a simple horn antenna, which looked out of the control room and could pick up interference. A week went by, and the signal didn't return. We finally learned the truth about 10 days after that big day. Suddenly, the signals were there again. Blasts of radio noise 8 times a second, coming in the 85-foot telescope. But just as strongly, they were coming in the little horn we had poked out the window. The signals had to be man-made radio interference. As we watched them, we saw them grow and fade as though they were being transmitted from a high-flying passing airplane, which is not quite as fun as aliens. And so, right as soon as anyone tried looking, what they found was that you don't find a signal right away necessarily. Like when he turned on the telescope, he thought maybe aliens had been blasting radio signals at us the whole time. And so they were just waiting for us to try to see if that was true. But it turns out that wasn't the case. And what did happen was that, sorry, I distracted myself with my joke that I put in here. What did happen, and what was a good lesson for SETI astronomers and for all astronomers, is that because we're looking for alien technology, it is easiest to sense our own technology. So when people do SETI, they're not actually looking for the little green men and women, right? They're looking for the technology that they use. We can't detect their little tiny bodies on little tiny distant planets. We have to look for their radio waves or their lasers or something like that. And so what we look for is the technology that's kind of similar to what we have. And so then we also see what we have. And that's part of why radio telescopes are usually far out, like in Green Bank, West Virginia, and there are actually laws there and in some other places where there are radio telescopes that you can't have a cell phone, you can't have a microwave, you can't have Wi-Fi, so that maybe someday somebody will have a real signal from aliens. Do you know this guy?
Oh, yeah. Who is it?
Actually, somebody else might be better at explaining who he is, or can tell me if I'm wrong. There's a show called Ancient Aliens. Is that right? Yeah, about the influence that aliens might have had on the history of Earth, this is a dubious show, and this is the scientist who has a I believe he has a doctorate in something. I'm not sure what it is, but he is always saying, I'm not saying it was aliens.
I think he's
but
an archaeologist.
Is it archaeologist? Okay, got it. That makes sense. And let's see. So in addition to picking up our own technology when we're trying to find something exactly the opposite, it's also kind of easy to pick up things that aren't really there at all, but we think are there because of our own human biases. And so I'm going to tell a story about this guy named Percival Lowell in the Martian canals. Mars doesn't have canals. That's the spoiler alert for this one. Sorry, everybody. And this is from the late 1800s, which is, a solid amount of time before anyone was doing SETI at all. And so this guy named Giovanni Schiaparelli, who was the director of an observatory in Milan, he started mapping these areas on Mars that he saw. Some areas were light and some areas were dark, and he called them seas and continents. And he also saw these little lines crisscrossing Mars, and he called them canali. And apologies to anyone who speaks Italian if I'm pronouncing that wrong. But it was mistranslated into English as canals. And when we have canals on Earth, it's because somebody built them. And so when that word came over into English, people thought, well, if there are canals on Mars, somebody must have built them. And this was especially true because they had just completed the Suez Canal here on Earth. And so we were kind of primed to see what we'd been doing on this other planet. And so most astronomers did not get too excited about this, really. But there was one guy, I don't know what was up with him exactly. He didn't have a lot else going on, I guess. So he just became really obsessed with this idea that was really just a mistranslation of a word. And he thought, there are these canals on Mars and I'm going to map all of them. And this is one of his maps. Right here, he eventually published 3 books about this, I believe. And he built an observatory in Flagstaff, Arizona called Lowell Observatory, which some people might have visited. I see some nodding, like people have been there. And part of his motivation was, I mean, it's great that it's there, but partly why it's there is because he wanted to find these canals. And he thought what he had made up in his head is that the Martians needed to move the water from the poles down to where they lived, kind of in the middle of the planet, which, I mean, if it doesn't not make sense. So his theories were, I believe, pretty widely known, and they ended up influencing the author H.G. Wells, who eventually went on to publish War of the Worlds. But it's not true unless you guys know something I don't. There are no canals on Mars and no canal builders. Does anybody want to fight me on that? Okay, just checking. And so this is a statement from a NASA historian about this whole thing. He says, most experienced astronomers never saw the Martian canals, and for a good reason. We now know they never existed. The network of crisscrossing lines covering the surface of Mars was only a product of the human tendency to see patterns, even when those patterns do not exist. And I would add to see our own technology out there in the universe, where it doesn't actually exist. My next story is about a woman named Jocelyn Bell. And I called this slide Jocelyn Bell, Pulsars and Little Green Men, which will explain itself in a second. So Jocelyn Bell, this is a picture of her, I believe, as a grad student. And she was working at a place called Mullard Radio Astronomy Observatory near Cambridge in England. And she was actually building a telescope, not that telescope, but a different one. Sorry, I should have found a picture of her with the telescope she actually built. And so she had hammered 1,000 posts, strung 2,000 antennas between them, and connected 120 miles of wire to make this radio telescope, which is pretty physical. Much more work than most astronomers do to have their telescopes, I think is fair to say. And it covered an area of about 4.5 acres. And they started operating in July 1967, and she, being a lowly grad student, was kind of in charge of all of the data taking. So every day it would come in on paper, had just a little pen, and it would show like how strong the signal was. So if really nothing was happening, it would be kind of like this, and then if a bunch of radio waves came in, it would jump up in a big plot. And one day she saw this thing, what she calls a bit of scruff. And that is that the repeating signal up there, that just kind of, this is the nothing, 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 spike, spike, spike. Does anybody notice anything interesting about those spikes? Yeah? Yeah, they go up and down, and kind of like the same distance from each other, right? Yeah. It looks pretty weird, and it didn't look like what people had seen coming from space before. You don't usually see things that regularly spaced. It looks kind of like, the noises that our technology makes. And so they were trying to figure it out. They thought it was our technology. They thought that what had happened to Frank Drake in the 1960s was happening to them. They were seeing some kind of interference. Maybe it was a radar, maybe it was a plane, maybe it was somebody's car engine. But every time they pointed their telescope at that spot in the sky, they saw this signal. And so eventually, when they finally couldn't figure it out, they decided to call it LGM-1. Does anybody guess what that stands for? Little Green Men 1. And it was half a joke, but kind of not really, because they'd ruled out human beings. They thought that stars in space, like I forgot to say that the distance between these happen every 1.3 seconds, which is way too fast normally for things that are happening in space. And so they thought, you know, it maybe wouldn't be the craziest thing to think if this was from aliens. But then there came a development in the case, which is that in another part of the sky, they saw basically the same thing, except it was 1.2 seconds apart, every 1.2 seconds. And the lesson that they learned was that one thing is an anomaly. Like if you find one thing, it seems totally insane, you've never seen any object like it, you know, it's not crazy to think maybe it could be aliens. But once you find two of kind of exactly the same thing, it's more likely that you found a new kind of object that you have never known about before. And the one that they found is called a pulsar, which is a star that is left after a supernova explodes. What's left kind of shrinks down in on itself, becomes super dense. It's basically the size of a city across, and it's made of neutrons, and it has the density of an atomic nucleus, and it spins around sometimes hundreds of times per second, and it has these radio waves that come out of its poles. Like, imagine this is radio waves and I'm a pulsar, and it spins around. I'm not going to do a good job, I'm not going to do that. But if it was a lighthouse, imagine, and it was sweeping around, every time it swept past you, you would see boop, boop, boop. And so, so Jocelyn Bell didn't detect aliens, but she did detect pulsars, and then other people won a lot of prizes about it. And yeah, that's what happens. Not anymore. And now we recognize the work that she's done, and she's still around, right? That's right. Okay. The next one is a Russian example, and this is an object called CTA-102, and it's not the world's prettiest picture, and that is because it's a radio picture, and I love radio astronomy, but it doesn't make the greatest images. And so in this picture, what this means is this is a very bright spot, and this is kind of fading radio emission. But this bright spot is really bright, and it seemed to be coming from really far away. And people in Caltech discovered this object and called it CTA-102. I'm sorry, I keep drinking water. My throat is really dry for some reason. Also, I'm not a tardigrade, and I need it. So in the early 1960s, astronomers discovered this object, and later that year, a guy in Russia named Nikolai Kardashev made a scale that he very humbly called the Kardashev scale. And in it, he describes different kinds of civilizations and how they might go about evolving their energy. Like, you might have heard, we have kind of an energy thing going on Earth now, where we talk a lot about what kinds of fuels we should be using and how effective they are and what damage they do. And he thought that that was going to be kind of a need and a concern whether you were here or on Alpha Centauri, and that as civilizations evolved, they would think of different really creative ways to find and harness energy. And so he grouped them into three categories. One being the Type 1 civilization, which is a group that harnesses all of the resources of a planet. And apparently, Carl Sagan estimated that Earth rates about 0.7 on the Kardashev scale. Does anybody disagree with that? Just checking. A Type 2 civilization harnesses all the radiation of a whole star. So some of you might have heard of a thing called Dyson spheres, which is a hypothetical thing where a civilization would put kind of a shell around its star, and kind of gather up all its energy and use it to do whatever alien civilizations do, I don't know. And a type 3 civilization harnesses the resources of a whole galaxy. And this estimates that humans might reach that type 3 civilization in a few 100,000 years to 1,000,000 years. So don't hold your breath, you know. And so what Kardashev had proposed, people in Russia thought, hey, maybe this really, really, really bright thing is evidence of a type 2 or 3 civilization harnessing its energy. And what we're seeing is the result of that. And that's not totally crazy, you know, like, unless you think it is. All of these things would be way more powerful and efficient than the things we have, and so it does make sense that a civilization might evolve that way. And so then another astronomer named Gennady Shlemitsky also found out that this object's emission was varying, kind of going up and down. And they made a public announcement, these astronomers, on April 12th, 1965, that caused a worldwide sensation, saying that maybe it was varying because aliens were modulating either their star or their galaxy. I don't know if anyone was around in 1965 and remembers that. Do you? What, can you tell us anything about it? Mm-hmm. Yeah. Right. Kind of like the pulsar example. We just needed to discover some more of them and really learn about their characteristics to learn this is not a crazy one-off thing from a crazy one-off alien civilization. It's a group of objects called quasars, and they are really distant and they are really bright, but they are just the bright black holes at the centers of active galaxies where there's a black hole, it's swallowing tons and tons of material and at the same time emitting all of this radiation that we can see from really far away. So the lesson that I took from this is that it's kind of good news because SETI keeps astronomers alert to all of these anomalies. When they discover something they can't yet explain, they try to explain it through non-alien means first. That would be the ideal thing. Here they just started with aliens. And discover something cool and new about the universe, but they keep aliens in the back of their minds as a last resort possibility. And here I have a story about Jill Tarter, who the book is about. She was in charge of a project called Project Phoenix, which was it followed a NASA project that had used the Arecibo radio telescope in Puerto Rico and a telescope in California to really, one of them was surveying a bunch of stars and looking for kind of really, really bright signals that might be coming from aliens, and the other was looking very deeply, more shallowly at really close nearby stars and kind of targeting them. But then NASA canceled that program. And so Jill Tarter and her companions got together, got a bunch of money, and just bought time on telescopes, like the one in Green Bank, West Virginia. And so this is a picture of a telescope in Green Bank called the 140-foot telescope. And behind it here is the big one called the Green Bank telescope. And so they had two telescopes. The main one was this one. And they would point it all over the sky, and at the same time they had a telescope in Georgia that was doing the same thing so that they could see if this one saw something, if the one in Georgia also saw it, then it was more likely to be real and not just somebody's spark plug or an alien, or not an alien going by overhead. That would be ideal. A jet or something like that going by overhead. But one day, the telescope in Woodbury was broken, so they didn't have anything to rule out whether it was just somebody's man-made interference. But they decided to go ahead with the observations anyway, and this was really not the day to have done that. So they saw the signal passing overhead, and they just kept on seeing it and kept on seeing it. And I thought I might try to read a little bit of a section. How are we doing on time?
You're doing fine.
Okay.
There's nothing to see outside anyway, so you can go on.
Okay. Got it. Just decide where to start. I'm helping the clouds to clear right now. Let's see. So, let's see. Sorry, I'm changing my talk at the last minute, which you're not supposed to do. So, they were seeing the signal, and they couldn't tell whether it was actually coming from space or what was going on, and they didn't have a way to check on it. And at the same time, there was this journalist who are the worst, and he that was a joke because I am one. He had called the SETI Institute looking for Jill Tarter. He just wanted to talk to her. And her administrative assistant had said, "She's not here right now, she's doing something interesting in Green Bank." And the journalist put his journalist ears up and was like, "I know what that means for people who are searching for aliens. That means you found something that might be aliens." And so he started calling around. He was from the New York Times. And so then they were under all this pressure to figure out what it was, because he was going to write a story maybe about what they were doing. And it turns out that what they had seen, and I'm not actually sure if he ended up writing an article about it, but what they saw was a satellite called SOHO. And if they had had the backup telescope working, if they had been able to get in touch with people who could have told them where the orbit of the satellite was, if they hadn't been being bothered by an annoying journalist, they wouldn't have had this panic attack of what they were going to do. And so the lesson that they took from it, apparently I didn't write my lesson down on this one, was that if you discover something, you're not going to be able to keep it a secret, because the New York Times is going to call you and be like, "Jill Tarter, what are you doing right now? I heard you're doing something interesting." And so now they have protocols for what to do in that event, and I'm going to get to those in a little bit. So that is even worse now, obviously, in the age of the internet. Has anybody ever heard of Tabby Star, or the alien megastructure? Does that ring a better bell? This comes from, it starts with stars. You may have heard they exist. And when planets, maybe some people haven't. When a planet passes in front of them, it kind of blocks a little bit of the light. So if I walked in front of that projection screen, I would block some of the light, and from your perspective. And telescopes can pick up on that, and that is how the Kepler Space Telescope worked. And normally that's just a very small percentage of the light, but in March 2011, in front of a star that is now called Tabby Star, something wandered across the front of it and blocked 15% of the light, which is a huge amount. I wrote down here, Jupiter just blocks 1% of the sun's light. So if you can imagine something that would block 15 times that, that's very large. And in February 2013, something blocked 22% of the light. And this was a discovery that was just kind of sitting in the database of data that they had from Kepler until a bunch of citizen scientists called Planet Hunters. Are any of you Planet Hunters? You should check it out. It's a citizen science program where you can go analyze data and find something as cool as this. So they saw this, and they also saw that there was a bunch of smaller dips in brightness as time went on. And they called the astronomer in charge, whose name was Tabitha Boyajian. And she was like, what could possibly be blocking that much of the light? And she came up with a lot of explanations. She thought it could be, I'll get to that part in a second. She thought it could be maybe a fragmented planet that had broken up and was kind of flying in front of the star, or maybe it was a swarm of comets that was doing kind of the same thing, or maybe it was a gas planet that was getting eaten by the star, a ring of dust around the star, variations around the star. she had a lot of different ideas. And so when she wrote a paper about them, she wanted to be funny. She's a funny person. And so she decided that it would be called the WTF star, which means where's the flux? And flux is basically brightness. So where's all the brightness? And that name didn't catch. I think the alien megastructure star, or Tabby star, really caught. But then, so if she was putting out a paper that gave all of these explanations, where does the alien explanation come from, right? It came from a guy named Jason Wright, who's an astronomer in Pennsylvania. And he was like, Tabitha, you should really consider the idea that this is maybe some kind of thing like this, or like a giant alien swimming pool in front of a star. Who knows what they want? It's a not implausible explanation for what's going on, and you can't rule it out, so you should rule it in as a possibility. And she was kind of hesitant, and then also he did an interview with the Atlantic magazine and mentioned the alien thing, so she didn't really have a choice but to deal with it at that point, because although the article did mention all of these possibilities, the only part of any article anyone notices is the, I'm not saying it's aliens, but it's aliens, part of the article. And so as soon as that happened, I don't know if you guys remember this happening, but there were just hundreds and hundreds of articles about how maybe there's an alien swimming pool in front of this star. They didn't say that exactly. Still, Tabitha, the original astronomer, was a little bit reluctant to embrace this idea. She really, she took to heart the lessons from the previous stuff. Like, if there's another explanation, you should probably look at that first. But then she kind of caught the excitement of all the people around her. Like, you can't rule it out. What if it is? And also, she was getting a lot of media attention. So she decided to kind of embrace it. And she started a discussion forum, which I think is still up. I think it's where'stheflux.com. We should look it up. You can go discuss results of the WTF star. And she also started a Kickstarter to see if they could just, yeah, it was a Kickstarter. And I was going to make a joke about how she was going to get her own swimming pool with it, but that's not true at all. That's not fair. I can't say that because this is going on the internet and it's slander. She did not do that. She wanted to monitor it with the Las Cumbres telescope network. Just kind of have constant eyes on it and be able to see, is the alien swimming pool passing in front of it right now or right now or right now. And she wasn't sure how it would work, but in 30 days, around 1,700 backers gave her $107,000. And she got a monitoring campaign, so that's a good thing aliens have achieved for us lately, I think. And I believe that they are still in the process of monitoring it, and I think that dust is the latest explanation that they've come up with that seems the best. And this one, too, I think is kind of similar to another lesson that a false positive is taught, which is that SETI helps us be alert to anomalies, and this false alarm helped astronomers find something new and weird in the universe, which is that sometimes stars do have crazy, crazy big changes in their light, and that probably is dust, kind of dustier dust than we've ever known before. And that's cool, even if the weird and new thing is not that we're not alone in the universe, which would obviously be the coolest thing, and we would all like to see that happen. Sorry. And this is the Russians again. They like SETI in Russia. They did when the United States was not doing very much at all in the 1970s. Over in the USSR, they were holding all kinds of conferences and doing observations, and more recently, they've actually transmitted signals for aliens to find, which we have been more reluctant to do. So it's kind of been a big thing historically, and so maybe this next example is not surprising. I think it was early 2017. A Russian astronomer gave a presentation about, quote, a strong signal in the direction of HD 164595, which is a sun-like star 94 light years away. They were using the Rattan 600 telescope. This is, oh, nope, wrong button. Wrong button. This is a picture of the telescope, which doesn't look very much like most telescopes, but looks kind of a little bit like one of the ones you guys have outside here. It's a radio telescope, and they just saw this burst of radio waves. It's a little bit like the WOW signal, if anybody remembers that signal. Just kind of a bright thing that appears once. Nobody knows where it comes from exactly, and neither did they. And so kind of like Jason Wright, the astronomer from the last slide, they said, hey, I'm not saying it's aliens, but maybe it's aliens. They presented this at a conference, and then astronomers kind of amongst themselves started passing around these PowerPoint slides like, hey, did you see the Russians said it's maybe aliens? Did you check this out? And then eventually a guy who runs a blog called Centauri Dreams, his name is Paul Gilster, got these slides and wrote an article about it. Always the journalists bringing news irresponsibly to the public. He dubbed it an interesting SETI candidate, and then just like every other, I'm not saying it's aliens, but time, there were tons of articles written about it. But there was very little evidence that anything interesting was going on at all. Like this telescope, it sees kind of a big, huge area in the sky as basically one pixel, and you can't tell where at all in this whole, like if this is the pixel, and I got a signal, it could be coming from here, or here, or here, or here, and you wouldn't even know where it was which part it was coming from. They didn't know what frequencies exactly it was coming in on, just kind of a big range, and they didn't know if it was that kind of narrow band signal like our radio stations, which is usually the way we think of how we might find technology. It could have been human interference. There was no way for them to tell whether it wasn't just, you know, I don't know, somebody turning on 50 Wi-Fi routers at once or something. And they looked at the same place 39 times, and they only saw this once. And they didn't call anyone else's telescope and say, hey, can you check this out and see if you see it also. So basically it was a thing that popped up once, went away, never saw again, don't know where it was, don't know exactly what it was like. And yet it got all this international attention. And in most other SETI systems, like in the SETI Institute systems, in a program called Breakthrough Listen, which is a big program right now that has $100 million to do SETI work, this would have just gotten thrown out, like something you only see once and then it goes away. Astronomers toss that out. You have to see it, 3, 4, 5 times the same way, and then other telescopes have to pick it up before it's taken seriously. But the lesson here is about the media and how even if there's no evidence it is ET, just kind of a question like, hey, maybe it could be, and there's no real reason to think so, people will get excited because aliens are very cool, right? Who thinks aliens are cool? That's a lot fewer people than believed in aliens. You guys have no faith in the aliens yourselves. I think they're pretty cool. So, I mean, it's understandable that when this is a possibility that's thrown out there, people get really excited. And we still keep making the same rookie mistakes of not ruling out our own technology because what this turned out to be was just a military satellite passing over. That's it, which is not that interesting. And seeing something once is not enough unless you see something once and it's secret designs for a secret spaceship. Then I think it's enough. But what if we really did see something, right? What if these people sent us a radio message? What would happen? Just like Jill Tarter and her friends discovered when they thought they had something really real and the New York Times was calling them, they needed to have an official protocol, and the very official name, people just call it the post-detection protocol for what they do if they think they see aliens. And it's actually called Concerning Activities Following the Direction of Extraterrestrial Intelligence. And it's put out by the United Nations. Yeah. Yeah, they had a study committee for a little bit. Actually, it might still be operating. I'm not sure. But yeah, they made this protocol, and no one is obligated to follow it, but it's kind of the best practices, and it's something that all SETI astronomers in the U.S. agree to. And so the first thing is to verify with your own telescope that the most plausible explanation is actually extraterrestrials. So figuring out, is it a radar? Is it a military satellite? Is it a telescope phoning home? And then you call somebody else who has a telescope, like I would call these guys, and be like, can you check it out? I found aliens, maybe. And then they would check it out and say, yeah, we found aliens also. This is the best case scenario. And then we would coordinate with people around the world who had telescopes so that when whatever star we were looking at set somebody else, it would be up in somebody else's sky. And then once all of those observatories, not all of them, but enough of them kind of agreed that yeah, this looks a whole lot like aliens and we think it's aliens, they would send in what astronomers call an astronomer's telegram, which is basically not a telegram at all, just an alert that something important is happening and can you please help us out. And then once it's fully vetted and seems real, which all of this would happen pretty fast really, then the next step, step 4, and the UN doesn't put it exactly this way, but I put it this way, is tell everybody. So, tell the governments of the world, tell the people of the world, tell the journalists, even though they've done bad things in the past, just don't keep it a secret. And so whenever I hear somebody say, if we found aliens, we'd keep it a secret, I think that is the last thing that any of these SETI astronomers want, because they've spent their whole lives looking for something that just never happens. And if they ever had evidence that it was real, I don't think that there's any government in the world that could stop them from just putting it on Twitter. And so this is my extra step 5, which is I promise that they will tell everybody. And then after that, there's other stuff they do, if it comes in at a certain frequency, they'll protect that frequency so that people can't keep broadcasting on it, so that it can be clear. They'll make all the data public so that everybody can see it, and they'll help get a group of researchers together to keep digging away at it. But that hasn't happened yet. Even though we've been doing SETI for the past 57 years and doing it pretty well, we really haven't made very much progress. In part because the universe is big and there's a lot to search, and in part because we've mostly been looking for radio transmissions from them, and we actually have no idea if they even make radio transmissions at all. We just think they might because we do, and now because we have lasers that are pretty good, we think maybe they have lasers also. But the truth is, we have no idea. We could be looking the totally wrong way. Jill Tarter likes to say this thing. It's like a conversational trick she pulls on people. She says, maybe they're using zeta rays. And then you're supposed to say, what are zeta rays? And she goes, I don't know. So, you get it? And then the lesson from that is a quote from her also, which is that we reserve the right to get smarter. As our own technology progresses, as we learn more about the universe and about the ways that you can transmit information within it, we can change what we're looking for, but that it's important to get started now, even if what we're doing turns out to be super rudimentary. Because if nobody ever gets started, nothing will ever happen. One day when I was writing the book, I decided to make this chart based on an estimate that Jill Tarter has for when she'll have done a good job, which is if she's looked at 1 million stars within 1,000 light years of Earth and looked at them at all the radio frequencies between 1 and 10 gigahertz. And if this is all of that, this is what SETI astronomers have done. Which is, I don't want to say they're doing a bad job, but they're not doing a great job. That's a joke. They're doing a great job. The universe is just big and there's a lot of stuff. And there's probably a lot more false alarms in our future, especially as we get to know different kinds of signals that we might look for. But maybe someday, one of those signals will be real instead. And that is the end of my talk. I'm happy to take questions. Yeah, and you can get up and leave without saying goodbye if you want, or I'm happy to take questions if you have any of them. Yes, the man who knows they're alien. I sure did. Yeah. Yes.
We are looking in the electromagnetic spectrum, that's all.
Yes.
Whether it's laser, infrared, X-rays, whatever.
Mm-hmm.
It only travels so fast. If something is 94 light years away,
Mm-hmm.
there's no chance for humankind to even do a single exchange. Electromagnetics is too slow. And when you're in the presence, or when you are blessed with being in the presence of one of these unidentified aerial phenomena machines, typically current ceases to flow, radio waves don't penetrate, all you hear on radios is static. You see extremely bright light, but it's an interference to electromagnetism, which only travels 3 meters per second.
Mm-hmm.
I realize we don't have any other window to look from Earth because we're babies, frankly. But I contend electromagnetism, and this is one of the reasons I got interested in radio astronomy. But it's too slow to cover all of, not quite infinite, no it's not, it's a bubble in space.
Yeah, it is
Where else
slow.
do we look? Let's think outside the box. Let's get out of our electromagnetic bias
Mm-hmm.
and look at something else. But then we ask, what? We don't know.
Yeah, no, I think that's the zeta rays. But I mean, you're right. And electromagnetic radiation is slow. And if we ever caught a signal from, say, 100 light years away, it would be 100 years old. It would. Right. Well, we have to just live longer. We have to make ourselves immortal, and then we could solve this whole problem instead.
The biologists are trying.
They are. Yes.
I have an easier question.
Okay.
I'm a little embarrassed to say. I already know what SETI is. I know what it stands for, but is it a research project? Is it an international consortium? Is it Carl Sagan's blah, blah, blah?
No, yeah, that's a really good question, and I think that it gets misused a lot in public, or used different ways. So SETI, the acronym on its own, just means like the field of searching for extraterrestrial intelligence. So it's a word like astronomy, like it just means a field. And then the organizations that study it have their own names. Like there's the SETI Institute, which is where Jill Tarter worked, based in...
Academic organization?
Yeah, it's a nonprofit organization. So, and their scientists...
It's not part of NASA. Right?
No, a lot of their scientists do have NASA grants, but it's it's like an independent nonprofit organization. They formed it when they formed it to get NASA grants because they had less overhead than other places. And then when NASA canceled the program, it was very convenient for them that they had this independent organization to do research. But people do use SETI, the word, to mean the SETI Institute, which I think gets confusing a lot of times.
Even amateur radio has a very small subset pursuing that.
You have a question?
So people are saying that like the aliens were real, we would see like their ships flying around in the night. Do you think that's true?
I don't think it has to be true. I think there could be aliens out there that are very far away or don't like traveling very much, and so don't build spaceships to come here. But I think that it could be the case that they do that, and so which is hard. That's a bad answer because it could be either way. Yeah, keep it secrets. Yeah, I'm sorry. I'm trying to think of a firm conclusion. Yeah, I wouldn't say that if you don't walk outside and see spaceships, that means there's not. I think there totally still could be, but also, wouldn't it be very cool if it did happen? Yeah. Wait, who said that? Oh, sorry. What'd you say?
Like in our library, my friend showed me this book where it had some old pictures and people think they saw UFOs in the background. But I'm getting confused. Like, no, yes.
Whether they are or they aren't.
Yes, but a lot are not.
Yeah, I think that, I mean, a lot of people are very interested in whether or not there are UFOs out there right now. And I think people ask Jill Tarter about this a lot, whether she believes in UFOs, and what she says is that she hasn't seen evidence of them that convinced her, but if she did, she would be willing to believe it. So, yes.
Well, when you talked about that Mars thing with the map, with the guy said that,
Mhm.
these two people still, is it true or not, or is it fake? About the canals.
About whether there are canals?
Yeah.
There are not canals out there, but the lines are there. But they're not forming a network of canals like people thought they were. It was just kind of, when you look at something for a long time, your eyes tend to kind of make patterns out of stuff, and so that's what was happening to them. But what they were seeing were real parts of pictures of Mars. But yeah, there's water on Mars. There's water on. And there's ice on Mars. And I mean, astronomers still think there could be life on Mars and that we just haven't found it yet. We haven't done a ton of exploring there, and we don't know exactly what we're looking for. I mean, probably not Martian elephants walking around, but maybe little tiny things.
In that respect, I would challenge anybody to look at the first 200 souls of Spirit. Look at the pictures carefully.
It's a good thing to do. NASA has a good archive of the pictures.
NASA will not. There's a gag. But any governmental agency cannot come out and say.
Well, but the pictures are there, regardless of what they're saying. Yes.
How do the scientists at the SETI Institute deal with the Fermi paradox, which is kind of a stark contrast thing to realize when you look at the age of just the Milky Way galaxy itself and the type 1, type 2 civilization transition in that whole paradox?
Yeah. So for people who don't know what the Fermi paradox is, it's basically, where is everybody? Like if, where are the aliens if there's so much stuff out there? Where is everybody? And I mean, I think that they would say they try to be agnostic about it. Like they are not trying to ask the question necessarily what would have happened to the people or the aliens that we might have seen, or why might we not be detecting them, but the ones who focus on detection focus on, like, if we can, how would we do it? But more recently, they're starting to give a little more thought to the sociology problem of it all.
The filters that occur in that.
Yeah. So they're recognizing and talking about one of the terms in the Drake equation, which is the equation that you can use to kind of estimate how many civilizations there might be in the galaxy. There's one that's L, which means the length of time that a civilization has technology and transmits things that we could pick up with telescopes. And that kind of makes all the difference in whether we find civilizations or not. Like, it's the difference between us being the only ones and there being many, many more is how long they live. And I think on astronomers' good days, they think, we're doing pretty well out here. Civilizations might last a while. And then some days you're like, oh no, we're all going to destroy ourselves tomorrow. And probably so did aliens. And so,
If I may say something, right now you heard rumblings. I mean, we're starting up a telescope. The moon is visible and Mars is visible. So, any more questions for those of you who want to go see the moon, all the craters, I mean, go up to the telescope.
sure.
And you can answer.
Yeah, I'll stick around as long as people want. No, I'm okay. Yeah, thanks. Yeah, thank you. That was a good question. What?